For section 5.1, we're going to look at equations in two variables. And what that means is that instead of just having x or y or t or z or whatever letter that you have to solve for, we now have two variables in our equations. And these equations usually have infinitely many solutions. So that means that we could plug in any number and get out an answer for the output. So the solution of our equations are an ordered pair that makes the equation true. So I could actually graph these, and they are going to be lines, straight lines on a graph, and any point on that line is a solution. And a line goes on forever in both directions, so that's why there's infinitely many solutions. So for example 1, you're going to be given an equation and an ordered pair, and you have to tell whether the ordered pair is a solution to the given equation. So in other words, is this ordered pair this point on the line of this graph? So for A, we are given x minus 2y equals 3, and we're given the ordered pair 5, 2. So we have to keep in mind that an ordered pair is always in the form of x, y. So the first number is always our x, and the second number is always our y. And then we're going to go ahead and plug those in to this equation where they go. So we're going to have 5 minus 2 times 2. And they're saying that if this is a solution, we will get an answer of 3. So this is really 5 minus 2 times 2 is 4. And they're saying 5 minus 4 would be 3. And it's actually 1. So this is not equal to it. So no, this is not a solution. For part B, we're given x minus 2y equals 3, and we're given the ordered pair 9, 3. So 9 is our x and 3 is our y. We're going to go ahead and plug those in. In order of operations, we're going to multiply. So we're going to have 9 minus 6 equals 3, and 9 minus 6 is 3. So 3 is equal to 3. So yes, this is true. So we're looking for a true statement once we plug those numbers in. Part C here, our problem gets a little bit bigger, and we're given the ordered pair of 0, 5. So everywhere there's an x is going to be 0, everywhere there's a y will be 5. So order of operations says to do parentheses first. So 0 plus 1 is 1. Then exponents, 1 squared would be 1. And then we have multiplication and addition left. So we're going to do the multiplication. 2 times 1 is 2. And 3 times 5 is 15. And they're saying 2 plus 15, which is 17, should equal 15. So no, this is not a solution. And then we're given the point, the same equation, but now the ordered pair 1, negative 1. So x is 1 and y is negative 1. So parentheses, 1 plus 1 would be 2. And 2 squared is 4. And then multiplication, 2 times 4 is 8, and 3 times negative 1 is a negative 3. And 8 plus negative 3 would leave us with 5. And 5 is not equal to 15, so no, this is not a solution either. Then you're going to be given a table and a graph, and you're going to be asked to find some solutions to the equation and then plot those on the coordinate plane. So we're given x plus y equals 5. So when we have to plug in an x value and figure out what y is, It's going to be a lot easier if we solve this equation for y. So just like in the last section we did when we rearranged equations, we solved for a different variable. That's exactly what we're going to do here. We're going to solve for y. So we have to get rid of this x. It's a positive x, so I'm going to minus x on both sides. And then I'll just have a positive y equals, and then I have 5 minus x here. So in the table, I'm given 6 different numbers that we're going to have to plug in here. So if I plug in -2, I'm going to have 5 minus a -2, which is really 5 plus 2. So the y would be 7, and an ordered pair would be -2, 7. And then if I plug in 0, 5 minus 0 is going to be 5. So my ordered pair would be 0, 5. If I plug in 1, 5 minus 1 is 4. So ordered pair 1, 4. And 3, so 5 minus 3 is 2. So 3, 2 for an ordered pair. And then 5 minus 5 is 0. So over 5 up 0. And then 5 minus 7 would be -2. So then we would have 7 comma -2. And then we have to plot those points. So on our ordered pair, remember crawl, climb. So for the first one, we're going to crawl to -2 and climb to 7. And then we're going to crawl to 0 and climb to 5. Then we're going to crawl to 1 and climb 4. And then we're going to crawl to 3 and climb 2. And then we're going to climb to crawl to 5 and climb 0. And crawl to 7 and climb -2. And we have our straight line. Example 2, the equation y equals 25,000x describes the average number of species y that become extinct in x years. Graph the solutions of this equation. So step 1, we need to create a table of values. So since this is a story problem, it has a meaning behind the letters, the variables. We need to decide, will it make sense to plug in negative numbers? So we're going to plug in numbers for x, and it says that become extinct in x years. So negative numbers would not make sense to have years. We're not going to have -5 years. We're going to have 5 years. So we are only going to pick positive numbers for our chart of numbers here. So I'm going to pick 1 year, 2 years, 3 years, and 4 years. So then we're going to plug that in. We're going to do 25,000 times 1, so that would be 25,000. 25,000 times 2 would be 50,000. And then times 3 would be 75,000 and 100,000. And then step 2 says plot these ordered pairs on a graph, and does it make sense to draw a line through the points in this particular problem? So let's graph it first. Remember our x's was 1, 2, 3, and 4 that we picked. Those are our years. And then we went up by 25,000s. Just going to label every other one there. So we had 1 was 25,000, 2 was 50,000, 3 is 75, and 4 was 100,000. So now let's talk about, does it make sense to connect these dots? So if we connect these dots, that means that we would have data at 1.5 years. So would it make sense to figure out, or would we be able to figure out how many animals were extinct in 1.5 years or 2.5 years or any number between the whole number of years? So if you think about it, species don't become extinct just on their yearly anniversary. Okay, they become extinct all throughout the year, no matter what, how long it's been. So yes, it would make sense to include all of these x values between the whole numbers. So with that being said, I'm going to connect these dots and have my straight line. And we could predict how many species would become extinct in 5, 10, 15 years using this data. Now, when would it be not acceptable to connect the dots? So if you think about if I gave you a quiz every Friday and we plotted the point your scores, well, then it wouldn't make sense to connect the dots because you're not taking a test all throughout the week. You're only doing it, or a quiz, you're only doing it on Friday. It's not something that continuously happens. It just happens once every week. So then you wouldn't connect. But if it's something that's continually happening, then yes, you connect those dots. So the assignment, even though I'm giving it today, which is Friday, the last day of the marking period, it's not due until Monday. So today's assignment will not go on until marking period 2.